Hello, Vicho. Let's read this question. This question says that a metal complex having the composition Cr, ammonia, four groups of ammonia and two chloride and one bromide, has been isolated in two forms, X and Y, right? And they have said that the form X reacts with AgNO3 to gives out white precipitate with AgNO3, and these white precipitates are soluble in the dilute aqueous ammonia, right? And then we have that the Y gives out the pale yellow precipitate soluble in the concentrated ammonia. So the Y will again react with AgNO3 and it will form the pale yellow precipitate, which is in short soluble in ammonia. And we have to find out the hybridization of the complex X and Y. So what are we given? We are first talking about X. We have X reacts with AgNO3 to gives out white precipitates, white PPTs. So if we talk about, we have this complex and we are writing, we use AgNO3 to distinguish which is the outer sphere ion present in the hair. Okay, so if it gives white precipitates means we are having here the formation of, AgCl, which means that this white precipitates are of AgCl. So now to formation of AgCl from AgNO3, which means that the outer sphere ion of our X complex should have Cl negative, right? So we have this one complex, and if we have to write X, from this we can conclude our X is equals to the formula something like this. Cl1 will take inside and we only need one outside the sphere, so we are writing this one outside the sphere. Okay, so this Cl will goes out with AgNO3 to form this white precipitates of AgCl. So now we have this formula for X, and if we see Y, we have Y, it reacts with AgNO3 to form the pale yellow PPTs, pale yellow PPT. And this pale yellow PPT is formed whenever we have AgBr. So this is the distinguished test. When we do AgNO3 test, we know that these two colors PPT are for which compound. So we can say that the Y has is a complex which has Br as a outer sphere ion. So from this we can conclude that our Y is equals to Cr NH3 4 Cl2, and we have here Br. We have both our X and Y formula. So now we have to go to the hybridization. For hybridization, we know in both of the chromium, you can see here also and here also, we have three positive ion. Chromium has three positive ion. So if we are taking, we know the electronic configuration of chromium is, we have in normal chromium we have Ar, and we have 3d5 4s1, and for chromium 3 positive we have Ar 3d3 4s0, and we have here three unpaired electrons. And from this structure I can draw the if we have to draw the orbital diagram for this one, we can draw it in this form. This is 3d, 1 2 3 4 and 5, and this is 4s, and this one is 4p. And in 3d we have three electrons, so 1 2 and 3. So rest these two orbitals of d, and rest all orbitals are vacant orbital for the reaction. So we can say here, so our hybridization will be of something like d2sp3, right? So we have both for both X and Y, we had chromium 3 positive, chromium 3 positive. So both will be having the same electronic configuration and both will be having the same hybridization. So we can say X and Y both have the hybridization of D2sp3. So, so for option, if we see option A, the first one they have said that the X hybridization is sp3d2. So this is wrong. We have correct option C. You can see here both are given D2 sp3 Here also they have given the opposite one, they have given the same, but it is sp3d2. This is also wrong. Here also it is wrong. Okay, so our option C is the correct option. So this was the solution, guys. I hope you understand the concept. Thank you.